Welcome back, everybody, for another deep dive. This time, we're tackling something that I think can be pretty intimidating for a lot of coders out there. We're talking about optimization problems in coding interviews. If you've ever thought about trying to get a job at a big tech company like one of the FAANG companies, you know that these types of optimization problems are kind of a favorite. They love to throw these at candidates. So picture this. You're in the interview, the pressure's on, and they hit you with a problem. And it's a problem that needs not just like a solution, but like the absolute best solution, like the most efficient, the most elegant solution. That's where optimization comes in. So that's what we're going to be diving into today. We've got some great excerpts from a guide that we found on the Algo Academy blog, which is kind of like a go-to resource, I think, for people who are preparing for these coding interviews. And so we're going to be kind of unpacking what optimization problems are, why they're so important in the interview process. And we're going to give you some proven strategies to approach them strategically. So to kind of kick things off, what exactly are optimization problems? And why do companies care so much about them?
Yeah, so optimization problems really are all about finding the best possible solution, not just any solution that works. It's about writing code that's not just functional, but also sleek and efficient.
I like that analogy of code that's sleek. But can you give us an example of what this looks like outside of the coding world? Something that maybe we can all kind of relate to a little bit better?
Absolutely. So imagine you're planning a road trip. Now you could take any random route to get to your destination, but you probably want to find the shortest, the fastest route
Right.
to get there. That's optimization in action. Or think about a company that's trying to, maximize its profits. They're going to be constantly looking for ways to optimize their operations, streamline processes, cut costs. These are all forms of optimization.
So it's kind of like finding the most efficient way to do something, whether it's planning a road trip or running a business. And that's kind of why companies use these problems in interviews. They want to see if you can think that way. Is that right?
Exactly. Optimization problems are a great way for interviewers to assess your problem-solving skills, your ability to write efficient code, and your understanding of how to apply these concepts to real-world scenarios. It shows them you're not just a code monkey, you're a strategic thinker.
Okay, that makes a lot of sense. But I think for a lot of people, the thought of like tackling these problems in an interview can be pretty daunting. So where do we even begin?
Well, the Algo Academy Guide offers a really helpful step-by-step approach that can help you break down these problems and stay calm under pressure.
Okay, I'm all for staying calm. So what's the first step in this process?
First step is understanding the problem. And I mean, truly understanding it. It's more than just reading the problem statement. It's about dissecting it.
So it's not enough to just like skim the problem. We need to like really dig into it.
Right. You need to understand the inputs, the expected outputs, any constraints, any potential pitfalls. Let's say the problem asks for the maximum sum subarray. You need to make sure you understand exactly what that means. Are we talking about a contiguous subarray? Are there any limitations on the size of the subarray? You need to be clear on all the details before you even think about writing code.
It's like making sure you have the right blueprint before you start building a house. You don't want to end up with a wonky structure.
Exactly. Getting the foundation right is crucial. Once you have a solid understanding of the problem, the next step might surprise you. It's about starting with a simple brute force solution, even if it's not the most efficient one.
Wait, so we're intentionally starting with the solution. That we know isn't ideal. Why wouldn't we jump right into finding the most optimized solution?
Well, this is about building a solid base. That simple brute force solution, we call it the naive solution. It serves a few important purposes. First, it ensures you understand the problem at its core. Second, it gives you a baseline to compare against when you start optimizing. And often it helps you spot those areas for improvement that you might miss if you try to be too clever too soon.
Okay, so it's kind of like sketching out a rough draft. Before you start painting the masterpiece, you're getting the basic idea down first, and then you can start refining it.
Precisely. And that refining process is where the real optimization magic happens. But before we dive into that, let's look at what a naive solution might look like for our maximum sum subarray problem.
Okay, so we've got this like naive solution and this kind of like first attempt at the problem, but we know it's not the most efficient. So how do we start finding those like opportunities to optimize?
Think of yourself as a detective looking for clues. Go back to your naive solution and start asking questions.
Yeah.
Are there any calculations we're doing repeatedly? Could we store those results and reuse them? Can we leverage any patterns or properties of the problem to our advantage? Is there a different data structure that might help?
So in the maximum sum subarray problem, like we saw that our naive approach was recalculating sums for overlapping subarrays, like over and over again. That seems like a prime opportunity for optimization.
Exactly. We're doing unnecessary work. And that's a big red flag. That's where knowing these common optimization techniques comes in handy. It's like having a toolbox full of specialized tools. You just need to know which one to use for the job.
Yeah, and that brings us to kind of the optimization toolkit
Mm,
that they talk about in the Algo Academy guide. And they break down these techniques so well. It's like having a cheat sheet for optimization.
absolutely. So let's unpack a few of those tools and see how they work in action. One powerful technique is dynamic programming, which sounds intimidating, but it's really about breaking down a problem into smaller, overlapping subproblems and solving those subproblems just once.
So instead of repeating the same calculations over and over, we can store the results and reuse them when needed. It's all about efficiency.
Precisely. Think of it like planning a road trip. You wouldn't try to figure out the entire route from start to finish in one go, would you?
No way.
You break it down into smaller legs, figure out the best route for each leg, and then combine them to create the optimal route for the entire trip.
That's a great analogy. So dynamic programming is like breaking down our problem into these smaller road trips, finding the best route for each one. What other tools are in this optimization toolbox?
Another useful technique is the greedy algorithm approach. And this is all about making the best local choice at each step, hoping it leads to the best global outcome.
So it's like choosing the shortest checkout line at the grocery store. Even if another one might open up later, sometimes you just got to trust your instincts and go with what seems best at the moment.
Yeah, that's the essence of a greedy algorithm. But it's important to remember that this approach doesn't always guarantee the absolute best solution. Sometimes that gut feeling might lead you down a less optimal path.
Interesting. So greedy algorithms are great for quick decisions, but we need to be mindful that they might not always give us the absolute best solution. What other techniques should we know about?
Let's talk about divide and conquer. This technique involves breaking down a problem into smaller, self-similar subproblems, solving them independently, and then combining the solutions to solve the original problem.
Okay, that sounds a little bit more complex. Can you give me an example that I can kind of wrap my head around?
Imagine you're sorting a deck of cards. You can use a divide and conquer approach by repeatedly splitting the deck in half, sorting each half, and then merging the sorted halves back together.
So it's kind of like breaking down this big, messy problem into smaller, more manageable chunks, solving those chunks, and then putting everything back together in a neat and tidy way. I'm starting to see a pattern here. A lot of these optimization techniques involve like breaking things down into smaller pieces.
You're absolutely right. Breaking down complex problems into smaller, more manageable units is a fundamental principle in computer science. And it's especially relevant when it comes to optimization.
Makes a lot of sense. What other tools are there?
We also have the two-pointer technique, which is particularly useful for efficiently searching or manipulating data in arrays.
Two pointers. How does that work?
Imagine you're trying to find a matching pair of socks from like a jumbled pile instead of starting at one end and checking each sock individually. You could use two pointers, one at each end of the pile, and you move the pointers towards each other, comparing the socks they point to. This way you can find the matching pair much faster than if you're using a single pointer.
Oh, that's clever. Work smarter, not harder.
Exactly. And speaking of working smarter, another powerful technique is the sliding window technique. Think of it like scanning a barcode. You're not analyzing the entire barcode at once, but rather a small window that moves across the barcode to gather the information you need.
Okay, so we've got dynamic programming, greedy algorithms, divide and conquer, two pointers, and sliding window. That's a lot of tools. So how do we know which one to use in a given situation?
That's where practice and experience come in. The more you work with these techniques, the better you'll get at recognizing patterns and understanding which tool is best suited for a particular problem. It's like any craft. The more you practice, the more intuitive it becomes.
So going back to our like maximum sum subarray problem, the Algo Academy guide shows how something called Kadane's algorithm can solve this much more efficiently using dynamic programming. And it takes a problem that was originally ON3 in complexity
Yeah.
and makes it ON, which is a huge improvement. But I have to admit, I don't fully grasp like how it achieves that.
Let's break it down. In the naive approach, we were recalculating the sum of every possible subarray. Kadane's algorithm cleverly avoids this redundancy. It keeps track of the maximum sum ending at each position in the array, building upon the previous maximums. This way, we only need to traverse the array once, resulting in that impressive ON complexity.
So instead of brute forcing our way through every combination, we're strategically using information we've already calculated to kind of build up to the final solution. That's pretty brilliant.
It's a beautiful example of how dynamic programming can transform a seemingly complex problem into an elegant and efficient solution. But it's not just about knowing the algorithm. It's about understanding why it works and being able to explain it clearly. That's what will really impress your interviewer.
Right. They want to see that you understand the underlying principles, not just that you've memorized a bunch of algorithms. And speaking of things that might trip us up, the Algo Academy Guide also highlights these common pitfalls to avoid when you're tackling optimization problems.
Yeah, those pitfalls are important to be aware of. They could be the difference between a smooth interview and a frustrating one.
Okay, so let's dive into those pitfalls and see how we can avoid them. So what's the first one we should be aware of?
The first one they mentioned is rushing to code. I can definitely see how it's tempting to just start typing as soon as you hear the problem,
Yeah.
especially when the pressure's on.
Yeah.
But that can lead to messy, inefficient code, wasted time. Take a moment to breathe, understand the problem, plan your approach before you start coding, and don't be afraid to talk it through with the interviewer. They're often there to help guide you.
So it's like planning that road trip again. We wouldn't just start driving randomly. We would take some time to map out our route first. Makes sense. What about what's the next pitfall?
Edge cases. Those are those pesky scenarios that can break your code if you're not careful.
Uh-huh.
Take empty inputs, extremely large numbers, or unexpected data types.
Those little gremlins that can sneak up on you. So how do we avoid them?
Thorough testing is key. Test your code with various inputs, especially those edge cases, to make sure it can handle anything thrown at it. And don't be afraid to discuss edge cases with your interviewer. It shows you're thinking critically and anticipating potential problems.
It's like making sure your house can withstand a hurricane, not just a gentle breeze. We got to build those robust solutions. Okay, what else should we watch out for?
Neglecting complexity analysis. This is all about understanding how efficient your solution is and how it scales with larger inputs. Interviewers love to see that you understand Big O notation.
Oh yeah, big O notation. I remember learning about that, but it's a little fuzzy for me now. Can you give us like a quick refresher?
Of course, Big O notation is a way to describe the performance of an algorithm. It tells us how the runtime or memory usage of an algorithm grows as the input size increases. For example, an algorithm with ON complexity means that its runtime increases linearly with the input size. So if you double the input size, the runtime roughly doubles as well.
So it's kind of like if you're baking cookies. A recipe with ON complexity might mean that if you double the batch size, you'll need roughly double the baking time.
That's a great analogy. Now imagine a recipe with ON2 complexity. That means if you double the batch size, the baking time could quadruple.
Whoa, that could turn into a long baking session.
Yeah.
Okay, so understanding big O notation helps us analyze like how efficient our code is, especially for large data sets. So what's the next pitfall to avoid?
Using the wrong data structure. Choosing the appropriate data structure for the task at hand can significantly impact the efficiency of your code.
It's like choosing the right tool for the job. You wouldn't use a hammer to screw in a light bulb.
Exactly. Each data structure has its own strengths and weaknesses. Do you need to list a set of dictionary? The choice can make a big difference. For example, if you need to check if an element exists in a collection, using a set will be much faster than using a list, especially for large collections.
So it's not just about writing code that works. It's about writing code that works efficiently. And that involves using the right data structures. Okay, what's the next pitfall we need to be aware of?
Overcomplicating things. Sometimes, in an attempt to impress the interviewer with their coding prowess, candidates end up writing overly complex solutions that are difficult to understand and debug.
It's like trying to bake a fancy multi-tiered cake, when a simple batch of cookies would have done the trick.
Yeah. Remember, simplicity and clarity are valuable. Start with a clear, concise solution and optimize it incrementally if needed. Explain your choices to the interviewer. They'll appreciate your thought process more than a convoluted solution they can't follow.
Keep it simple, optimize strategically, communicate clearly.
Got it. What's the last pitfall on our list? Ignoring the interviewer. They're not just there to judge you, they're often there to help guide you and see how you think.
Okay, so don't be afraid to ask clarifying questions. Explain your thought process. And treat the interview as like a collaborative problem-solving session. That's a good reminder to keep in mind. Well, we've covered a lot of ground today. I feel like we've really unpacked what optimization problems are, why they matter so much in these coding interviews. We've explored that step-by-step approach to tackling them. We've learned about those common pitfalls to avoid. I feel like I have a much better grasp of how to approach these problems now.
Yeah, and remember, practice is key. The more you practice, the more comfortable you'll become
Yeah,
with these techniques and concepts.
well said. Thanks for joining us for this deep dive into the world of optimization. We hope you found it helpful and maybe even a little bit inspiring. Until next time, happy coding.